Welcome back everybody to Trigonometry. What we're going to do in this video is start to look at some applications of trigonometry. So far what we've done is use the sine, cos and tan ratios to find unknown side lengths in a right angled triangle. We've also been able to find unknown angles in right angled triangles given two sides. What we can do with that knowledge, with those skills, is apply them to applications or worded questions, real life problems. Now I've started off trigonometry applications. That should be your next little heading, applications, your subheading in your summary book. I would like you to jot down these 2 points here. A diagram is always essential with these problems. Sometimes you are given the diagram and you need to fill in some relevant information. Other times you may not be given it at all, so you need to draw the diagram and you must label it appropriately. One other thing that we must look at before we can attempt applications problems is two different types of angles that we might be faced with. The first one is called the angle of elevation. I'll just zoom up a little bit for you. So this is actually going to be another little subheading. Angles of elevation. We have one other angle, angle of depression. This is what an angle of elevation will look like. Have a look at this diagram. I've got the horizontal, so this might be the ground. It's not necessarily on the ground. You could be on the top of a mountain or something like that. Basically, this is the horizontal. This eye here, this shows where the line of sight is. So this person down here is actually looking up at that bird in the sky. The angle of elevation is measured from the horizontal. So from this horizontal, from the ground in this picture, up to the line of sight, which is this dotted line here, looking up at the bird. What I'm going to do is actually label that there as the line of sight. So for an angle of elevation, you are looking up and at an object. Okay, so let's try and remember that as well. So when you are looking up at an object, so again, measured from the horizontal there, we can see in here, that little arc, that's our theta, that's the angle that we're talking about. So we might like to draw that diagram there in the summary book as well, with this little dot point looking up at an object. You might like to pause to do that. The second angle that we'll look at is called the angle of depression. This is what the angle of depression looks like. Notice again we have a horizontal drawn in. This is because both the angles of elevation and depression are always measured from the horizontal. So we might actually go back, if I just go back to this here, looking up at an object, we might also want to make a point that it's measured from the horizontal. If you've got that drawing there, I mean, it does show it in that. But just as a little reminder, measured from the horizontal. Okay, let's go back to angle of depression. Notice that this time the eye is up here and the line of sight down there is looking down at the object. This time the person is higher than the object, they are looking down at it. What we can do is draw a horizontal out from where that person is, and the angle of depression will be measured from that horizontal down to the line of sight, like we have here. Now you might be able to see that if I was to draw a line from here straight down to that little boat, yacht there, we would have a right angle triangle in there. So it wasn't marked on our original drawing, but you can see that if we just dropped a straight vertical line down from those two, from that horizontal there, we would have a right angle in between. Okay, let's put that also into our summary book, but we'll add another point, and that is that it's looking down. Oops, I better get the right tool for that. Oh dear. Just bear with me. There we go, that's better. Looking down. There we go. Looking down at an object. And again, you must be careful here because it is measured from the horizontal. From the horizontal. Let's put that in there as well. The reason I'm emphasizing that is one of the common mistakes is to, when you're drawing these diagrams, is to put the angle of depression in here. Can we see that there is the vertical? That is a vertical line. By putting the angle in there, you're actually measuring it from the vertical to the line of sight, and that's not correct. The angle of depression will always be measured from the horizontal. So what I need to do now is undo that little drawing I've done there so that we don't put that into our diagram. We don't want that. That is incorrect to put the angle there. Pause here and put the angle of depression, just a rough sketch. You don't have to draw it exactly like it's put in there. You don't have to colour it in like it's coloured as well. Just a rough sketch, however you wish, to highlight where this angle of depression is measured. What we'll do now is actually look at a couple of examples. Before we do that, there's one thing that we should cover, and that's that the angle of elevation will equal the angle of depression. This is a handy little skill to have, a handy little thing to know. Now, we want to first know why. Why are these two angles the same? You'll notice that I've put two lines here, and I've put arrows on them. That's to indicate that they are parallel lines, okay? This little arrow here and that one there indicates these are parallel lines. I'll highlight something else for you as well, which might give you a clue as to why these are parallel line, why these are equal, I should say. Why these two angles here, elevation and depression, why are they equal? If I put a little line here, and then one following down there, and then a third across here, can you see that I've formed a Z? There's a Z there. Now I wonder, thinking back to year 8, can you remember Z angles? You might remember that a Z angle, that's an alternate angle. Alternate. And alternate angles in parallel lines are equal. So Z angle, alternate angles in parallel lines are equal. So this might, in some of the problems that you do, you might need to actually recognize that I might have a triangle down here. I might be given the angle of depression up there. To help me, what I can do is replicate whatever the angle is there down within this triangle here, and that may help me solve an unknown side or angle. Pop that into your summary book as well. Okay, so just the angle of elevation equals the angle of depression. You might like to draw a little picture to show you why, or just a little dot point to say that they are Z angles or they are alternate angles in parallel lines. What is important is that we can remember that these two are equal. That is the most important thing. Let's start to have a look at an example now. Here we go. Typical question, worded. We've got sort of the basic structure of the diagram drawn for us, but we're going to have to add some information in. So first of all, we must read the question, and we're going to have a look. There's going to be some important information here. Cable of length 45 meters is anchored from the ground, so it means it's attached to the ground, or it's being held down on the ground, to the top of a communications mast. So looking at this diagram, I can see this is the cable here. on that hypotenuse, and the mast, the communications mast, is this here, the vertical. The angle of elevation of the cable to the top of the mast is 60 degrees. So angle of elevation, so if we're looking from the bottom up to the top, angle of elevation is in there. Find the height of the communications mast to the nearest meter. So the height is the height of this here. We are actually finding this. I'm going to put H for height. We're trying to find how tall it is. Let's put in that other information we were given. We were given that the angle of elevation was 60 degrees, so I'm going to put that in there. And we were also given the length of the cable. The length of the cable, so it's attached down here and it goes all the way to the top there. So that is 45 meters long. Have a look what we've got here now. A right angle triangle, an angle. One side we're trying to find and the another side given. You might like to pause here and see if you can work out the height. The first step, if you hopefully you've had a go at trying this, but the first step always, you should be labeling your triangle. Opposite this reference angle here, I have the opposite side. Opposite the right angle, I have the hypotenuse side. I've got O and H, that's the sine ratio. Next step, substitute your values in. And finally, let's multiply both sides. I might write H equals sine 60 times by 45. Now remember, calculator always. With trigonometry problems, you will need it. I'm typing that into my calculator now. Sine 60 multiplied by 45. And I get 38.97. Now remember in the question up here it said to the nearest meter. So if I've got 38.97 meters, what I'm going to do is round that up to 39 meters. I always like to look at my answer and check if it makes sense with the triangle I'm given. This opposite side should be shorter than the hypotenuse because the hypotenuse is always the longest side. It's 39 meters. That does make sense. If this is 45, that is longer than the 39. So that's our first example there. You may like to pause here and put this into your book. The second and final example that I'll do for this video, because it is quite a long video at the moment, is this angle of depression example. So let's enter the information in. I've got angle of depression from the lighthouse beacon, so that's this up here, 112 meters above sea level. Okay, so 112 meters, this beacon is 112 meters above sea levels, 112 meters in there. To a boat that is a horizontal distance of 1.5 kilometers from the lighthouse. So I might just pick a different color here. 1.5 kilometers, 1.5 kilometers. There we go. Find the angle of depression. So I'm actually looking for this in here. Remember, angle of depression is measured from the horizontal down to the line of sight. Now what I've got here is a triangle. I've got two side lengths and I'm trying to find an angle. At the moment that angle is not marked within my triangle. But I know that I've got parallel lines here, a Z angle. This is the angle of depression, which will be equal to the angle of elevation. So from the boat, looking back up to the top of the lighthouse, these two angles will be the same. Now I have a triangle, two sides that I know, and also this angle. Before I begin, I have noticed something. You may have noticed it as well. This is measured in meters here, isn't it? And this here is measured in kilometers. Now that's going to cause a problem. If I try and do this calculation, leaving those numbers as they are, I'm going to get an incorrect answer. I'm going to convert this to meters so that they're both in meters. So 1.5 kilometers, that's 1,500 meters. So I'm actually going to use those two values now, 112 and 1,500. All right, before I can begin, I need to label. I have the opposite side. I have the adjacent side. O and A is tan. Opposite, 112. Adjacent, 1,500. Now remember, when we're finding an angle, we use our inverse function. That's how I would set that up. Finally, into your calculator, you would type the inverse of tan and then 112 over 1,500. And I get an answer. Now have a look up here. It says round to 0.1 of a degree. So I need to round to one decimal place, and I get 4.3 degrees when I do that. So just a little angle. It's not a big angle, but we can see that the boat is very far away. So of course it would be a small angle. Let's put that also into our summary books. Now ladies, I'm going to do another video with some more examples. They are pretty lengthy, so I'm not going to keep going with this one. We'll end this video here. You've got 2 examples already, and we've had a look at also angles of depression and angles of elevation.